Hello and welcome back. Now we're looking at catalysts and reaction rates. Catalysts are pretty cool. We talked about them before. We're just going to look at how catalysts work, how they work in terms of our thermochemistry, okay, and how they affect reaction rates and the fact that they are not consumed. All right, moving on. So, catalysis, deals with the properties and development of a catalyst and the effects of catalysts on chemical reactions. So a catalyst is a substance that increases the rate of a chemical reaction, okay, kiddos? So it makes it happen faster without being consumed. This is really important. They are not consumed in the overall process. So I can add a catalyst. It's not actually part of the reaction. It just helps speed up the reaction rate and it's not consumed, which means once I add a catalyst, that catalyst continues being a catalyst for as many reactions as you want because it's never consumed, it's never eaten up. So chlorophyll is a catalyst for photosynthesis, which is pretty cool. The inside of a catalytic converter in a car exhaust system is coated with an alloy that acts as a catalyst for the combustion of exhaust gases. So that's pretty cool. We use catalysts everywhere, and catalysts are actually found in nature, but they're more like enzymes. A catalyst lowers the activation energy. So for thermo in particular, what a catalyst is going to do is going to lower the activation energy. So it's going to bring that down. So this is an uncatalyzed reaction. You need more activation energy. If I add a catalyst, it's going to lower the activation energy required for the reaction to occur. And essentially what it does is provides a new pathway. So here's the original pathway without the catalyst. And if I add a catalyst, I'm going to get a new pathway. Less energy required. So this results in a larger number of effective collisions between entities, so the reaction rate increases. So again, let's talk a little bit about that. The reaction rate increases. Why? Because there's a larger number of effective collisions. So that's cool. So far, what we've learned is the catalyst is required to lower the activation energy. Awesome, got it. The rate of the forward reaction and of the reverse reaction increases by the same amount. We're actually going to have some formative on this because this is really important. This is the forward reaction, kiddos. Okay, and actually if I flip this around, and let me just clean this up a little bit. So this is actually the forward reaction where it's going do. Okay, the reverse reaction is actually going like that. So the mirror image of this diagram is the reverse reaction. Biological catalysts or enzymes have binding sites specific to the reactants or the substrate. The enzyme temporarily binds the substrate molecules and aligns them in the proper orientation. So we use enzymes in our bodies, and nature has a way of making things more efficient. And catalysts are just everywhere, kiddos. So let's talk a little bit about uncatalyzed decomposition of methanoic acid. The uncatalyzed reaction proceeds slowly at room temperature. But if I add a catalyst, right, a catalyzed decomposition of methanoic acid, the catalyzed reaction has a lower activation energy, thus having an increased rate. In this case, it was just a strong acid, okay, the catalyst. So anyhow, take a look. And all you have to know is that it decreases the activation energy, causing the reaction to increase, the reaction rate to increase. It is important to note that the chemical composition and amount of the catalyst is the same from start to finish of the reaction because it's not consumed, right? A catalyst, again, is a substance that increases the rate of a chemical reaction without being consumed. Okay, increases rate. And it's not consumed. So I don't have to keep adding more and more and more. So here again is the activation energy needed, right? And it goes from reactants to the top of the activated complex. And if I add a catalyst, that's just going to go down, causing a new pathway. And this is the amount of activation energy required, and this is the new activated complex. So here are some uses of catalysts in the oil industry. Basically, those are things that you don't have to really know, just know that they exist. These kinds of things may show up as an info bit, so a little bit of like information, background info in order to answer a question. Catalysts are used in the cracking and reforming of crude oil, which reduces the temperature required for these processes, making them more efficient. And reducing the temperature is really important because that when you're messing around with temperature in nature, it really messes up, especially when you're dealing with water. It messes up the dissolved oxygen in the water, and it really actually kills a lot of aquatic life. Upgrading of bitumen from oil sands, because we live in Alberta, we're going to have real life examples. So we use catalysts for the process of upgrading bitumen. And we use catalysts for emissions control. And natural enzymes as catalysts are a thing, right? This is more of a bio thing, but these are just examples that you can look at your leisure. Definitely don't have to memorize these at all. Don't waste your time. These are just things that are going to show up on an info bit or some, like I said, precursor information to answer a question. If you want to take a video, look at a video. It's in the Google Classroom. But for right now, we're going to be done. Now, in saying that, I want to see if I can record the video. No, it's not going to take the sound. Okay, bye-bye.